Good morning to all of you. In the previous session, we discussed to identify the cross correlation of discrete time signals. I solved one example. In today's session, we'll be going through example where we'll be identifying autocorrelation of the given sequence. So here, an example is there. We have to determine autocorrelation sequence for sequence x of n. Okay, that means we have to identify rx of l. So in case of autocorrelation, the same sequence will get autocorrelated with itself, right? So again, you will write down the sequence here, the given sequence or discrete time signal x of n is equals to 0, 2, -1, 3, 1, 0, and so on. Origin at 3. The autocorrelation for sequence x of n is the formula rxx of l is equals to summation n is equals to minus infinity to infinity x of n into x of n minus l. Okay, so these two sequences will be there. Okay, that is x of n will get correlated with x of n itself. Okay, so therefore this autocorrelation is indicated as rxx. Okay, will cross correlation were denoted as rxy of l. In example, if it has been asked to determine the autocorrelation sequences of the following sequences, and you have been provided with x of n and y of n. Okay, so two different sequences are provided, but in example, if it has been asked to identify the autocorrelation, so in that case you will be separately identifying rxx of l and then ryy of l. Okay, that means you will be identifying autocorrelation of first sequence x of n with itself, and then identifying autocorrelation of second sequence y of n with itself, that is ryy of l. So while solving example, you should read carefully what has been asked in the example, right? So here this rx autocorrelation is given as rxx of l is equals to summation n minus infinity to infinity x of n into x of n minus l. So again we'll solve it for different values of l. Okay, so for l is equals to 0, what you will get rxx of 0 is equals to summation n is equals to minus infinity to infinity x of n into x of n. Okay, because I am substituting value of l is equals to 0, right? So the product sequence again you can indicate it as v of 0, right? So x of n is getting multiplied with x of n, so the same sequence is getting multiplied with itself. So 3 multiplied by 3 will be 9 at origin, right? Then 1 multiplied by 1 will be 1, then the remaining are 0, right? So then on left hand side minus 1 get multiplied with minus 1, so it will be 1, right? Then 2 multiplied by 2 will be 4, 0, and so on. Okay, so when you will add all these values, so you will get rxx of 0 value. So this will be 5, 6 and 15. Okay, so that is 9 plus 1 10 plus 14 plus 1 15. So rxx of 0 will be 15, right? Similarly for l is equals to 1, we'll get formula rxx of 1 is equals to summation n is equals to minus infinity to infinity x of n into x of n minus 1. And I'm substituting value of l is equals to 1. Okay, so it will be x of n minus 1. So from x of n you can identify x of n minus 1 by delaying it, right? The remaining sample values will be same, only origin position will be changing, right? 0, and so on. So if you are delaying it, so the sample which is coming at 0 time unit, it will come at the 1 time unit. So origin will be shifted on left. Okay. So again you will be multiplying this sequence, that is x of n will get multiplied with x of n minus 1. You have to multiply this with x of n, right? So the product sequence you can indicate as v of 1, right? So at origin value is minus 1, here it is 3, so it will be minus 3. Next value is 1, 1 getting multiplied with 3 will be again 3, right? Next value is 1, but here it is 0, so it will be 0, and so on. Similarly on left hand side there is 2, 2 will get multiplied with minus 1, so it will be minus 2, right? Similarly after 2 there is value 0, so remaining values will be 0. So if you sum these values, so you will get x of 1, and the value you will get is minus 2. So rxx of 1 will be minus 2. Similarly you will find it for L is equals to 2. So the formula for that will be rxx of 2 is equals to summation n is equals to minus infinity to infinity x of n into x of n minus 2, right? So again rewrite the given sequence here. What was your x of n? So x of n given in the example is 0 2 minus 1 3 1, okay. 0 2 minus 1 3 1, okay. Origin at 3 0 and so on. So to get x of n minus 2, you have to delay this sequence, okay. It will be delayed by 2, so origin will be shifted by 2 position on left, okay. So origin will be at this 2 here, right? 2 minus 1 3 1 0 and so again. To get the product sequence, you can indicate product sequence v of 2. This x of n minus 2 will get multiplied with x of n. So at origin value is 2 here, here it is 3, so multiplication will be 6, 6 will be at origin. Next value is minus 1, here it is 1, so multiplication will be minus 1. Next value is 3, here it is 0, so remaining values will be 0, right? Similarly on left hand side all values are 0 here, so 0 will be there. So if you sum up these values, so it will be rxx of 2, and it will be equals to 6 minus 1, so it will be 5. Similarly you can identify it for L is equals to 3, so you will get formula rxx of 3 is equals to summation n is equals to minus infinity to infinity x of n into x of n minus 3. So x of n minus 3, again the sample values will be same, it will be 0 2 minus 1 3 1 0 and so on. Origin at 3, so it is delayed by 3, so it will be shifted to left by 3 samples, so it will be at this 0, right? So again x of n minus 3 will be multiplied with x of n, product sequence will be indicated v of 3. So at origin 0 value is there, in x of n origin 3 values there, so multiplication will be 0, right? Next value is 2, so it is 1, so 2 multiplied by 1 will be 2. Next value minus 1, but the remaining value is 0, so it will be 0 and so on. And on left hand side all values are 0 here, right? So if you sum up these values, so you will get rxx of 3, so rxx of 3 will be 2, right? Similarly for L is equals to 4, we will get rxx of 4 is equals to summation n is equals to minus infinity to infinity x of n into x of n minus 4. So again x of n minus 4, so sequence values will be same, that is 2 minus 1 3 1 0 and so on, delayed by 4, so 1 2 3 4, so origin will be at this position. Product sequence you can indicate as p of 4. At origin value is 0 here, here it is 3, if you multiply you will get 0, right? Next value is 0, Again multiplication will be 0, next value is 2, but here it is 0. So again you will get 0 and so on. On left hand side again you will be getting 0 values, right? So Rx of 4 will be 0. So that means your Rx value will be 0 for L greater than or equals to 4. Okay, so for L greater than or equals to 4, the autocorrelation value will be 0. Similarly, you can identify it for L is equals to minus 1. Okay, and I will rewrite this x of n sequence here. So x of n is 0 to that value, 2 minus 1 3 1, 2 minus 1 3 1, 0 and so on. Originate 3, right? So for L is equals to minus 1, you will get Rxx of minus 1, right? Summation n is equals to minus infinity to infinity x of n into x of n minus minus 1, so it will be n plus 1. So you have to advance x of n by one sample, so simply it will be 0 2 minus 1 3 1 0. Okay, so origin will be shifted to right by one position, right? So it will be at this one. Again the product sequence, again v of minus 1, so v of minus origin value is 1, here it is 3, so multiplication will be 3. On the right hand side it is 1, here it is 0, so remaining values will be 0. On the left hand side 3 is there, here minus 1, so it will be minus 3, right? Next minus 1 value is there, so minus 1 multiplied by 2 will be minus 2. Remaining values are 0 here, so 0. So Rx of minus 1 will be equals to, this will be minus 3 plus 3, it will be 0 to minus 2, right? So it will be simply minus 2. Similarly for L is equals to minus 2, you will get Rx of minus 2, that will be equals to summation n is equals to minus infinity to infinity x of n into x of n plus 2, right? So x of n plus 2 will be equals to, again sequence will be same, 0 2 minus 1 3 1 0 0, right? And so on. So origin will be shifted by 2 position to right? So it was at 3, so now it will be at this 0. So again you will multiply and product sequence will be a v of minus 2, right? So at origin value is 0, here 3, so multiplication will be obviously 0, the remaining values on right hand side are 0. So from origin onwards you will get value 0. On left hand side 1 is there, 1 will get multiplied with minus 1, it will be minus 1, right? Next value is 3, so 3 will get multiplied by 2, so it will be 6. Then value is minus 1, but remaining values are 0, so it will be 0. So 6 minus 1 will be 5, so your Rx of minus 2 will be 5. Similarly for L is equals to minus 3, you will get Rx of minus 3 equals to summation n minus infinity to infinity x of n into x of n plus 3. So x of n plus 3 will be equals to, again values will be same, 0 2 minus 1 3 1 0 0 and so on. So origin will be shifted by 3 position to right, it is at initially 3, so 1 2 3 shifted by 3 on right. So again the product sequence can be indicated by v of minus 3, so at origin value is 0, right? 0 multiplied by 3 will be 0, right? And 0 onwards the remaining values are 0. On left hand side the first value is 0, so 0 multiplied by any value will be 0. Next value is 1, so 1 will get multiplied with 2, right? So it will be 2, and again the remaining values are 0 here, right? So you will get all values are 0. Okay, so we will get it as Rx of minus 3 is equals to 2, right? So we can identify it for L is equals to minus 4, right? So the formula will be Rx of minus 4 is equal to summation n is equal to minus infinity to infinity x of n into x of n plus 4, right? So x of n plus 4 will be equal to, again, sequence values are same, that is let 0 2 minus 1 3 1 0 2 minus 1 3 1 and 0 0 0. So origin was at 3, it will be shifted by 4 1 2 3 4. Okay, so again you will multiply it with x of n. So product sequence you can get a value of minus 4, right? At origin value is 0, so it will be 0 multiplication, right? On the right hand side all values are 0, right? On left hand side two values are 0, right? Then third value is 1. Okay, but on left hand side there is no third value, that is again it is 0, so it will be 0 simply, and so on. So this Rx of minus 4 will be 0. That means the autocorrelation sequence will be 0 for L less than or equals to minus 4. Right? So finally, you can write down the answer. The autocorrelation sequence of N is Rx of L is equals to, write down the complete sequence here. At origin you get value 15, then minus 2, and 15, then minus 2 is there. After that, right, and is equal to 2 5 2 0, right? 5 2, the remaining values are 0. Similarly on negative side, for minus 1 minus 2 5 2, minus 2 5 2, right? And minus 4 onwards, again these values are 0. Okay, so you can observe here the same values are repeated on left hand side of the origin, which are same as right hand side of the origin. Okay, so minus 252. So that is the required answer for the autocorrelation of x of n. Okay, so this is how you will be again solving the autocorrelation or finding the autocorrelation sequence, where you will be using only one sequence to correlate that sequence with itself, right? Again here for finding autocorrelation you will be performing three operations, that is shifting, multiplication and addition, and you will be substituting different values of L in the autocorrelation formula, starting with 0, and then on positive side that is 1 2 3 and so on till you doesn't get the 0 value of autocorrelation sequence. Similarly you can substitute for negative values of L. Okay, you can identify it for negative values of L, starting from minus 1 minus 2 minus 3 and so on until you doesn't get the 0 value. So in next session we will be discussing Z transform and how that Z transform can be used in the analysis of LTI systems. Okay, how the response of LTI system can be identified by using Z transform. Okay, so that topic we'll be discussing in the next session. So thank you for joining this session.